Hi everyone, this is Ramesh and welcome to my channel. Today we are going to be learn the chapter named Lines and Angles. We across the many situations in our day-to-day life where we find the lines and angles. At every corner there we can see some angle position, and the boundaries of this board or boundaries of your phone or walls, there we can see the lines. There are many usefuls by learning these angles. While a flight is taking up and landing, there they see the position, angle position of a flight. So there are many uses about the lines and angles. So in this video, I would like to give you a complete introduction about the lines and angles chapter. This is useful for from classes 6 to 10 complete basics. So I would like to cover complete information about these lines and angles. If you are perfect in this, you can do it very easily some of the problems from the chapter. So let us learn without wasting time. So here, first one, let me learn about what is a point. What is a point? Point is denoted by a dot. Point is denoted by a dot. A dot is useful to locate a location. If you want to locate a location, that we can show by a point. A point, a set of points can make a line segments, lines or rays, anything. With only points, we can make the geometrical figures. All the geometrical figures made by a set of points. So a point is widthless. It doesn't have a width and it doesn't have a length according to the Euclid. A point cannot be measured according to the Euclid. Euclid is known as father of geometry. These lines and angles also comes a topic in the geometry itself. So here point cannot be measured, a widthless and lengthless. Okay. Now then next one will go for about line segment. Line segment. Line segment symbol is the shortest distance between 2 points. The shortest distance between the 2 points is known as a line segment. Suppose here there is a 1 point and here there is a 1 point. Point A and point B. If you join a line between these two, it is called as a line segment. Yes. A line which has 2 end points. A line which has 2 end points is known as a line segment. So it has 2 end points. See, first A and B. 2 end points. And it can be measurable. We can measure the length of the line segment. See, a line segment or line, everything is formed by a set of points. Some infinitive, some points if you join, it can make a line segment or line or anything. So next we would like to learn. We have to learn about a ray. A line which has 1 end point and one side we can extend infinitely, endless. This we can extend infinitely. It's called as a ray. Suppose the AB line segment we want to show, we can show like a AB line segment lines. Now, if the ray you want to show, here A, B, it is a ray. So we can show in the symbolical form. At top of the alphabets we need to show this is a ray symbol. If you want to read AB ray, AB line segment, that symbol, line segment symbol is this. So that symbol can be seen on the top of the alphabet. Here ray symbol can be seen here. Yes, AB ray. Yes, now a ray cannot be measured. We cannot measure the length of the ray because here is this arrow says that we can extend this line infinitely. We cannot be measured. Suppose sun raises. I am watching you people. That means my eye raises are endless. I cannot be measured. Yes. So this is ray. Now next we will learn about line. A line is cannot be measured and it can be extended on the both the directions infinitely. It has endless. A line has endless and it can be extended in the both the directions infinitely. So see, it can be extended till the infinity. Here, left side and right side, we can extend infinitely. And a line cannot be measurable. We cannot measure the length of the line. See, if you want to show that symbolical form of a line, as we can show like this, AB line. AB line. I would like to tell you one more thing here. It is a AB ray. AB ray and these two are different, not same. AB ray, this ray is moving this side. A to B. The B side we can extend infinitely. Here, B to A side we can extend infinitely. Both are different in the symbolical form. Okay, here we like to be, now we have to learn about the line. Line can be extended infinitely in the both the directions. So if you cut a line, we can see the two rays. If you cut a line, we get a two rays. I hope you understand what is point. A line segment. A line segment has two endpoints and it can be measured. A ray and line cannot be measurable. A ray has only one endpoint and one side we can extend infinitely, and a line cannot be measurable and it can be extended both the directions infinitely. And next we will have to learn about parallel lines. Parallel lines. What is meaning of parallel lines? We normally knows everybody what is meaning of parallel line. If two lines, if these two lines, line M, line L and M, L line and M line, these two lines are with a fixed distance and they doesn't have any common point. They are not intersected each other, and those lines having with a fixed distance till endless, till infinitely. If we extend these two lines also, they will never intersect each other. The lines which doesn't have any common point, these two lines doesn't have any common points, and this line if we extend infinitely, the distance between these two lines is constant, and those lines are always called as a parallel lines. And here line L and line M. If you want to show the symbolical form of the parallel line, we can show like L is parallel to M, and this is a parallel symbol. Okay, L is parallel to M, and this is symbolical form. If you see this in the textbook, that you need to will know that L and M are two lines, they are parallel. L is parallel to M or M is parallel to L. If you don't leave, it's possible, like you know. Next we will have to, now I would like to tell you that intersecting line. Intersecting lines. Intersecting lines. If two lines having a common point, if two lines having a one common point, then the two lines are called as a intersect lines. Here, one line L and line M. If these two lines having a same common point, L line having this point here and line M also having same point. So this point is on line L and line M. So these two lines having a common point, hence these two lines are called intersecting lines. These two lines are parallel lines. Here these two lines are intersecting lines. If two lines having a same common point, then the lines are called as a intersecting lines. Parallel lines and intersecting lines. I hope you understand the difference between the parallel lines and intersecting lines. So let me tell you some more. I will draw some here figures to tell me either they are intersecting lines or parallel lines. So here these two lines are intersecting lines or parallel lines? These two are intersecting lines. Now, these two lines are parallel lines or intersecting lines? Parallel lines. Now these two lines parallel or intersecting lines? This is not a parallel line and this is not an intersecting line, but it will consider as a intersecting only. This third examples lines are called intersecting lines itself. Why they are called as intersecting? They doesn't have any common point, even though they are considering these lines are intersecting lines, because here these two are the lines and these lines can be extended infinitely. As we extend this line, definitely they intersect each other at one point. So we have to be consider these two lines as intersecting lines itself. See, these two lines are parallel lines. They have fixed distance between these two lines, so they are parallel lines. And however, these two lines having one common point, they are intersecting lines. Here, now at present, these two lines doesn't have a fixed distance and they are not intersecting, but they intersect in the future if you extend. So these lines also will consider in the group of intersecting lines. I hope you understand the difference now. Now let me go for concurrent lines. This is the new word. Try to learn. Concurrent lines. Here the concurrent line intersecting lines, to see they are similar but they are different to each other. Here let me draw the figures to be understand the concurrent lines. See the figure? Yes. Here, if two lines having the same common point, that means if two lines having a common point, then the two lines are called as the intersecting line. If more than two lines, it may be 3 lines or 4 or 5 or 6, more than two lines having the same point, common point, if they are same intersection point, if more than two lines having the same point, then the lines are called as a concurrent lines. If two lines are intersecting each other, they are called as a intersecting line. If more than two lines are intersecting each other at same point, they are called as a concurrent lines. I hope you understand the difference between these lines. Till now we have discussed about only lines. Again, based on lines, there are different kind of angles made by the transversal that will be different. Before that, we must learn about the angles now. So let us enter into the topic of angles. Try to note these all points. Write this all the points so that you will be know what we are learning it. After the class also you can recall if you write a notes. So writing notes is very good. In the math, if you want to really learn math, you must practice several times to get good knowledge. So let us learn about the angles. What is meaning of angles first? What is meaning of angle? Angle. Where the angle will form? If two rays having same common point, at the position of common point, the angle will form. If two rays having a same common point, if they have a common point, at the position of common point, angle will form. Suppose, let me take here OA is a one ray, OB is a another ray. These two rays having a common point O. At the position of this point, this angle will form here. Angle will form here. I hope you understand. If two rays having a common point, at the position of common point, angle will be. At every corner we can see the angles. Okay. Now model, like let's go for in the angles. There are two kinds of rays here. As I said, OB and OA. There are two rays here. In these two rays, one ray is constant. It does not move anywhere. It's called as a initial ray. Suppose this initial ray. The ray which moves continuously like a clock needle. The ray which continuously moves is known as a terminal ray. Initial ray just does not move anywhere. It's called as a initial. It will be there only. And the terminal ray will move like that. Suppose these two are the rays. If this ray is initial ray, it does not move anywhere, and this ray is known as the terminal ray. Suppose if terminal ray moves, the angle will be increases continuously like so. Based on the position of these two, initial ray and terminal ray, the positions of moving initial ray and terminal ray, the angles are changes. So we have types of angles also based on the position of the initial ray and the terminal ray. So let us learn the types of angles. Types of angles. So first type of angle is zero angle. What is zero angle? Zero angle always denoted by 0 degrees. And the position of initial ray and terminal ray are initial ray. Suppose this is OA, here initial ray. Okay, here OB is a terminal ray. The initial ray and terminal rays are on the same direction, and one ray is upon another ray. There is no moving, there is no displacement between these two rays. So these two rays having zero angle. There is no angle formed. At exactly 12 o'clock. So 12 o'clock, exactly 12 o'clock in the clock, where we can see the zero angle between the needle, minute's hand and hour's hand. If you are not considering a second's hand. Okay, then we can always think about these angles in the clocks. There, if you see the angles between the clocks, it is more effective to learn about the angles. Next, I would like to tell you about acute angle. Acute angle. Here, the angles between 0 to 90 degrees are called as a acute angle. The angle between 0 degrees to 90 degrees are called acute angles. Between 0 to 90, that means here 1 degree to 89 degrees, all the angles are known as a acute angles. The minimum measurement of angle we measure by the protractor, that is 1 degree. Less than 1 degree we cannot be measured by the protractor. There are other measurements where we can measure the angles less than 1 degree also. But the available instrument which has to measure the angle, that is protractor. With the protractor we can only measure minimum 1 degree, maximum 180 degrees. There are 360 degrees protractors also available in the market, where there you can buy and see the 360 degrees angles of protractors. Here the angles between the 0 degrees and 90 degrees are called as a acute angles. Let me draw the acute angles figures here. This is O and A. OA is a initial ray. OB may be here or here or here or anywhere. If OB wherever it stands, this complete angles are give us acute angles. That means more than 0 degrees and less than 90 degrees, complete angles are known as a acute angles. These all angles are known as a acute angles. Next, the third type of angle is that the right angle. Right angle. So here right angle measurement is 90 degrees. If the initial ray and terminal ray perpendicular to each other, then the angle made between the two rays are exactly 90 degrees only. So here 90 degrees, the angle between the initial ray and terminal ray is 90 degrees. Then the angles are called as a right angles. Suppose this is O and A, OA and OB. This angle is 90 degrees. So here is a right angle. You can see the right angle very easily. We can identify the right angle. It will be in the L shape. So exactly 3 o'clock right angle or 9 o'clock. Also the angle between the here 3 o'clock here is 90 degrees. Suppose 9 o'clock here the angle also will be 90 degrees in the clock. So next must we learn about obtuse angle. Obtuse angle, the angle between 90 degrees to 180 degrees. So the angles between 90 degrees to 180 degrees. The angles between the 90 degrees to 180 degrees, all the angles are known as a obtuse angle. So more than 90 degrees and less than 180 degrees angles are known as a obtuse angles. More than 90 degrees, less than 180 degrees. So let me take here. This is 90 degrees. If I draw any angle here in this, it will be what angles has been done? This all rays are what angles? These are the acute angles, and this is 90 degrees angle. More than this 90 degrees, wherever the ray is present here, this complete angles are known as a obtuse angles. This complete angle is known as a obtuse angles. 180 degrees means a straight line. This is known as a 180 degrees. Above 90 degrees, and this is 180 degrees. 90 degrees and 180 degrees. Okay, this between this, wherever this ray presents, the angles are known as a obtuse angles. Obtuse angles symbols will be like this always. This is obtuse angle. In the obtuse angles, we can find 190 degrees and acute angles also. So obtuse angle is more than right angle. That we need to be remembered. So next, I would like to tell you about straight angle. Straight angle. Straight angle measurement is 180 degrees. So straight angle, here itself there is a meaning and name, that is straight angle. So a straight line, this always gives, suppose this is O and A and B. It's the OA is the initial ray and OB is the terminal ray. If initial ray and terminal ray in the opposite direction, then the angles are formed between the two rays are 180 degrees. So one semicircle makes here, see. The position of angles increases. When 0 degrees, there is no angle formed. Here is the angle formed. By an arc I am showing this. This is called as an arc. If arc is increases, angle also increases. Here arc is increased again. Here arc is increased more than acute angle. Here arc is increased more than obtuse angle. See, semicircle angle. If there is a semicircle, you remember a complete circle occupy the 360 degrees. That means it's making 360 degrees angles. A semicircle makes 180 degrees angle. Like our protractor also will be in the semicircle only. It gives us 180 degrees. Okay, here straight angle. If initial ray and terminal ray in the opposite direction, the angle makes here 180 degrees. So next, sixth one is reflex angles. Reflex angles. Reflex angles between 180 degrees and 360 degrees. Okay, the reflex angles are always above 180 degrees and below 360 degrees. All the angles are known as a reflex angles. Let me take you. Here, suppose this is O and A and B. Now, what we can say here? This is angle is 180 degrees actually. Straight angle I drawn. More than straight angle, more than 180 degrees, less than 360 degrees. Here, more than 180 degrees. This all place. If B position is somewhere here, that means the angle is increases like this. So, reflect angles. Reflex angles. More than 180 degrees and less than 360 degrees angles are known as a reflex angles. Next, last type of angles are known as a complete angle. The complete angle is measured by 360 degrees. 360 degrees. Complete angle. Here, a terminal ray completes one rotation and it's come to the initial ray position. The terminal ray complete one rotation and come to the initial ray position. Again, same direction. The initial ray and terminal ray will be in the same direction. But here the terminal ray complete one rotation. Then 360 degrees will form here. Suppose let me take here. This is OA is a initial ray and OB ray is starting like making acute angles here and going like this and made a right angle, then making a obtuse angle and straight angle, then reflect angle and coming to the initial position to the uninitial ray. So here you can see the one complete rotation. Here the angle arc, the position of arc you can see. The position of arc is made 360 degrees. 360 degrees. So here 0 angle and complete angle look like same, but in the 0 angle the terminal ray does not move. It is on the initial ray itself. There is no gap between the initial ray and terminal ray. But here terminal ray completes one rotation. It crosses all the angles and come to the initial place again. Then it forms a 360 degrees angles. So these are the 7 types of angles. One is 0 angle, next one is acute angle, then right angle, obtuse angle, straight angle, reflex angle and complete angle. In this way, if you remember in the order, it is very easy to be remember you. And the figures, the diagram you must be remember. This diagrams helps you lot because we need to be identify which angle it is. Whenever you draw a rectangle, see the angles here directly we can say they are 90 degrees. If I draw one parallelogram, see here these two are the acute angles and these two are the obtuse angles. Obtuse angles and acute angles. So if you see the position of the angle, that is very important, and based on the position of angle we can say which type of angle it is. That is very important about the angles. Next we have to be learn about the different kind of angles. So here the types of angles are completed. Then the operations of angles. So there will be here where sum of two angles it gives 90 degrees. What it was? If two angles if you add, the sum you got 90 degrees. This is called as a complementary angles. If two angles if you are adding, if sum is 180 degrees, they are called as a supplementary angles. If two angles you are adding, if you are getting 360 degrees, what is called? Let us learn that completely, step by step. First one is complementary angles. If you add any two angles, if you get 90 degrees, the sum of two angles if give us 90 degrees, they are known as a complementary angles. If sum of any two angles if you add that is equal to 90 degrees, they are known as a complementary angles. Suppose 30 degrees plus 60 degrees equal to 90 degrees. Here sum of these two angles is 90 degrees. So 30 degrees is a complementary angle of 60 degrees and 60 degrees is a complementary angle of 30 degrees to each other. This 30 degrees and 60 degrees are complementary angles to each other. If we add these two angles, we will get a 90 degrees. Let's see the 30 degrees here lines. Suppose this is 30 degrees. Okay, now we have like 60 degrees lines. Suppose 60 degrees I have taken lines. Okay, if you join these two, you get a 90 degrees. If you join these two lines, okay, you get exactly a 90 degrees. If sum of two angles, if you get a 90 degrees, they are known as a complementary angles to each other. So the complementary angles, in the complementary angles, we always use the acute angles. Both angles also we get acute angles only. So here we won't get more than acute angles. Like here we won't get any obtuse angle. One obtuse angle, one acute angles cannot make a complementary angle. Obtuse angle itself, it is the more than 90 degrees. So more than 90 degrees, if you add any other obtuse angle, you take, suppose let me take 100 degrees. Plus you add any acute angle, it will more than the 90 degrees only. It's more than 90 degrees only. So it cannot make a complementary angle. So to make a complementary angle, the both angles whatever we are taking it, they must be acute angles. And the complementary angles which are equal to each other, they are 45 degrees and 45 degrees. This 45 degrees and 45 degrees, they are same, equal to each other and makes a complementary angle. These two angles are equal and they make a complementary angles. That is 90 degrees. Next we have to learn about supplementary angles. Supplementary angles. Same. Here the concept is, if sum of any two angles, if give us 180 degrees, if sum of two angles, if give us 180 degrees, they are known as a supplementary angles. Suppose 30 degrees plus, to get 180 degrees we need 150 degrees. They are known as a supplementary angles. 30 degrees plus 150 degrees. Supplementary angles. Suppose 30 degrees is like this. And 180 degrees, suppose let me draw the 180 degrees now. Sorry, 150 degrees. Here 150 degrees, obtuse angle and one acute angle. If you join this both, we get a straight angle like 150 and 30 degrees. So here we get 180 degrees. If sum of two angles give us 180 degrees, they are known as a supplementary angle. Here 30 degrees is a supplementary angle of 150 degrees and 150 degrees is a supplementary angle of 30 degrees. So now here in this we need to observe. To get a supplementary angle, definitely we require one obtuse angle and the other one is acute angle. One obtuse angle, one acute angle we can find in the supplementary angles. And there are two equal angles which make a supplementary angles. The two angles are both right angles. 90 degrees plus 90 degrees will give us 180 degrees. 180 degrees. So here, next we have to learn about conjugate angles. Third one. Conjugate angles. Conjugate angles. Here, sum of two angles is 180 degrees, supplementary angle. If sum of two angles is 90 degrees, complementary angle. If sum of two angles is give us 360 degrees, they are known as a conjugate angles. Suppose, let me take again same 30 degrees plus 330 degrees, that equal to 360 degrees. Okay, here these two angles are known as a conjugate angles. Conjugate angles. In this we can see one reflex angle, the other one maybe obtuse angle or acute angle or right angle, whatever. One reflex angle we can definitely see in this, and the other one obtuse or acute angle, and or not right angle we can see that. Or not, there are two conjugate angles each other. They are means 180 degrees and 180 degrees. 180 degrees plus 180 degrees. These two, if you add, you will get a 360 degrees, and these two are conjugate to each other. These two are supplementary to each other. So here we need to learn about this complementary angles, supplementary angles, and conjugate angles. If you add any two angles, if you get 90 degrees, they are known as a complementary angles. If you add any two angles, if you get 180 degrees, they are known as a supplementary angles. If you add any two angles, if you get a 360 degrees, they are known as a conjugate angles. I hope you understand the information about the complementary and supplementary and conjugate angles. Next, we have to learn about linear pair angles. Okay, linear pair angles. I would like to tell you about the linear pair angles. This is important to learn. Linear pair angles. Before that, let us learn adjacent angles. Adjacent angles. Adjacent angles in the sense there are two angles. Suppose OA, B, C. Here 20 degrees and here let's say 30 degrees. So adjacent angles are there. Just to decide if two angles having same vertex, common vertex and common arm. Here common vertex, here this is common arm, or ray, common ray. These two angles 20 degrees and 30 degrees having common vertex and common arm. So these two angles known as adjacent angles. These two angles are known as the adjacent angles. But just beside angles, pakka unna angles ne adjacent angles antam. So adar madhya gap undadu. See 20 degrees and 30 degrees. They must be have one common vertex and common arm. So common vertex and common arm. If the two angles having same common vertex and common arm, then the two angles are known as a adjacent angles. See, adjacent angles. We can also say the adjacent angles here. Here 30 degrees and 150 degrees. These two angles are known as a what? Adjacent. These two angles are known as a adjacent angles. These two angles having common vertex here and common arm here. So they are known as a adjacent angles. Remember. Now next we have to learn about linear pair angles. Linear pair angles. Linear pair angles. If sum of two adjacent angles, if give us a straight line or 180 degrees or a supplementary known as a linear pair angles. If sum of two adjacent angles is give us 180 degrees, they are known as a linear pair angles. Suppose we can write here, see. 30 degrees and or not, let me take here now 40 degrees and here 140 degrees. Sum of these two adjacent angles is giving 180 degrees. So these two angles are, this is known as a linear pair angles. See, sum of these two angles, sum of these two adjacent angles, these two are the adjacent angles. Add these two adjacent angles, are they giving 180 degrees? No. So these are not a linear pair angles. So let's see here, sum of these two adjacent angles, these two are the adjacent angles because they have common vertex and common arm. If the angles having common vertex and common arm, they are known as the adjacent angles. And here the two adjacent angles and giving a sum is 180 degrees. The sum is 180 degrees. So here 30 degrees and 50 degrees, 180 degrees. These two angles are known as the linear pair angles. And here also these two are known as the adjacent angles. These two adjacent angles, sum is giving 180 degrees are a straight line. Straight line is nothing but just now we have learned that is 180 degrees. Same only. Okay. So the sum of two adjacent angles give us 180 degrees are a straight line or a supplementary. These two are the supplementary angles also. They are known as a linear pair angles. Very important concept. There must be adjacent angles and they have to give 180 degrees. So see, now linear pair angles always adjacent angles, but adjacent angles not always linear pair. See, linear pair angles, these are the linear pair angles. Let me take one more example. Here 60 degrees and here 120 degrees. These are the linear pair angles. These two adjacent angles, because they have common vertex and common arm, and sum of 120 plus 60 is 180 degrees. So linear pair angles. And linear pair angles always adjacent angles. In the definition of linear pair itself, we have the sum of two adjacent angles. This gives us 180 degrees. They are known as a linear pair. So linear pair angles are always adjacent angles. The adjacent angles are always linear pair? No. The adjacent angles are always not a linear pair, because these two are the adjacent angles. 20 degrees and 30 degrees. But this sum is 50 degrees is not equal to 180 degrees. So they are not a linear pair angles. So adjacent angles are always not a linear pair angles, but linear pair angles always adjacent angles. And about the supplementary angles and linear pair angles also we have questions. What is the difference between the supplementary angles and linear pair angles? Here the supplementary angle, suppose let me take here 120 degrees, here 60 degrees, here 120 degrees is 60 degrees. If you add 120 degrees plus 60 degrees, that is equal to 180 degrees. The sum of two angles, if give us 180 degrees, they are known as supplementary angles. If sum of two adjacent angles is give us 180 degrees, they are known as a linear pair angles. I hope you understand. Here to get this sum of two adjacent angles, if you are adding two angles, that must be adjacent angles. That means they should have a common vertex and common arm. They are known as a linear pair angles. But here there is no condition that it should be having common vertex and common arm. It may be a different figures. It may be a different angles. Here there is no condition of that having common vertex and common arm to get a 180 degrees. You add any two angles, if you are getting 180 degrees, either diagrams are different. If you are adding those angles, if you are getting a 180 degrees, then they are known as a supplementary angles. See, 120 and 60, they are different diagrams, but these angles are known as a supplementary angles. But here, these angles cannot be said as a linear pair angles, because they doesn't have a common vertex and common arm. You know the difference between them. Yes, that is what supplementary angles and linear pair angles. But see, if you join this both, then we get a linear pair angles. Here, linear pair angles are always supplementary, but supplementary angles are not a linear pair. Linear pair angles, these two are the linear pair angles. They are supplementary angles only, 140 plus 40 degrees, 180 degrees. So, if you are adding two angles, getting 180 degrees, that is supplementary. No matter either they have common vertex or common arm. But to tell about linear pair angles, we must be think about either the two angles are adjacent angles or not. Adjacent angle in a sense, they should have common vertex and common arm. But in the case of supplementary angle, we won't think that just we add the two angles. If you are getting 180 degrees, they are supplementary. We won't think about the common vertex and common arm in the case of supplementary angles. So remember, linear pair angles always adjacent angles, linear pair angles always supplementary angles. But adjacent angles not always linear pair and supplementary angles not always linear pair angles. I hope you understand the difference between these. Now, the angles made by transversal. It is very important. This is very important to learn, children. The angles made by transversal. What is meaning of transversal? Let us learn here. The angles made by transversals. Transversal. What is meaning of transversal? Let me tell you here first. If there is a line here, line M, and there is a one line here, N. Here, N is parallel to N. M line is parallel to N. So, one line is intersecting these two parallel lines at two distinct points, two different points. A line is intersecting two parallel lines at two distinct points. Suppose L. L is a line is intersecting these two parallel lines at two distinct points. Then the line is here. This is nothing but this is passing through the. This is transferring through these two parallel lines, and this line is known as a transversal. So this line is known as a transversal. The line which is passing through the two parallel lines, the line is known as a transversal. If these are two lines here, and one line is intersecting two lines, two parallel lines, the line is known as a transversal. When transversal is there and there is when one line is intersecting two parallel lines, then there is a 8 angles will form here. What are the 8 angles? Let's know that 1, 2, 3, 4, 5, 6, 7. Okay, 5, 6, 7 and 8. There are 8 angles are formed. When 8 angles will form, when two lines are parallel, one line is intersecting two parallel lines, then there is immediately 8 angles will form. So the relation between these angles that we are going to learn now. So the relation between these angles we are going to be learn now. So let me draw this diagram little small to understand now. Here I will draw this. See, this is line, and this is one more line, and this is known as a transversal line M, N, L. Transversal. So angles form now 1, 2, 3, 4, 5, 6, 7, 8. 8 angles are formed. Where the transversal intersecting on the parallel line, there 8 angles are formed. So now the angles made by this transversal we have to learn. There are 3 kinds of angles we can find. One is corresponding angles. The next one is alternative angles. The third one is vertically opposite angles. So here we must be know that before going to learn these 3, what are the interior angles and what are the exterior angles. Interior angles, inside of this parallel lines, angles are known as a interior angles. 2, 3, 5, 8 angles are known as a interior angles. Interior angles. Interior angles. Interior angles are what here? Angle 2, comma, angle 3, comma, angle 5, comma, angle 8. This is angle symbol, children. Angle symbol. In this we will write angle. Now exterior angles. Exterior angles. Exterior angles are what? Angle 4, sorry, angle 1, angle 4, angle 6, angle 7. Angle 1, comma, angle 4, comma, angle 6 and angle 7. They are known as a exterior angles. Now you got angles. That means what is interior angles and what is exterior angles. You got idea. Now let's go for corresponding angles. First one is corresponding angles. Corresponding angles. What are the meaning of corresponding angle? When we are studying about the corresponding angles, you must be remember one thing. We have to take only one side of the transversal. There are two sides of the transversal, no? Left side of the transversal and the right side of the transversal. So you take one side of the transversal. One is interior and one exterior angles are known as a corresponding angles, but not adjacent angles. Remember, one side of the transversal, one interior angle you take it and one exterior angle you take it, and but not the adjacent angles. They are known as the corresponding angles and they are always equal. The corresponding angles are always equal. What are the corresponding angles? One side of the transversal, one interior, one exterior angle, but not the adjacent angles are known as a corresponding angles. Let's take angle 1. And angle 2 you should not take because this angle 1 and angle 2 are known as the adjacent angles. But I said, but not the adjacent angles. No. Here angle 1, exterior angle. Let's take one interior angle. We have to must be take as a angle 5. So corresponding angle. See, angle 1 is always equal to angle 5. The corresponding angles are always equal. When two lines are parallel, one line is intersecting to these two parallel lines, then corresponding angles are equal. The corresponding angles are that one side of the transversal, one interior, one exterior angles, but not adjacent angles are known as a corresponding angles. They are always equal. Now angle 1 is equal to angle 5, and let's see here angle 2. 2 is the interior angle. Now we have to take one exterior angle, one interior, one exterior. One interior angle 2 and one exterior angle 6. This angle 2 is equal to angle 6. Yes. So these angles are always equal. Only we have taken a left side of the transversal. Let's take the right side of the transversal also. See here. Angle 4 if we are taking, angle 8 we have to take. These two angles are equal always. Suppose angle 4 equal to 60 degrees. Here also you will get a 60 degrees only. Because if you know the angle 4 they have given in the question, you find out at the position of angle 8, it is also 60 degrees according to the corresponding angle condition. According to the corresponding angle condition. Here it is 60 degrees, here also will be 60 degrees. Then angle 4 is equal to angle 8. And next angle 3 is equal to angle 7. See now, if you know the one of the angle, we can find the corresponding angle of it. Angle 1 if you know, angle 5 also you know. Angle 2 you know, angle 6 also you know. That means if you know the one of the angle, we can find out the rest of all angles. Suppose, let's see that this angle 1 equal to 120 degrees suppose. Angle 1 equal to 120. Then angle 5 also 120. According to the corresponding angles are equal. Then here, what about these two angles? These two angles are known as the adjacent angles, are nothing but a linear pair angles, because these two angles, angle 1 and angle 2, are having common vertex here and they have common arm. So they are known as the linear pair angles. Linear pair angles always makes 180 degrees no. So see, 120 degrees is completed. The next one is here 60 degrees. 120 plus 60, 180 degrees. So it is completed now. That means here 2 is equal to 6 according to the corresponding angle. So here also will get a 60 degrees. So simple. In this way we can find out the right side also. Here see, here 120 degrees. These two also, angle 1 and angle 4. They are known as the adjacent angles. Again we have to get here 60 degrees. These two are the adjacent angles. Adjacent angles, that means linear pair angles, always 180 degrees no. So 60 degrees plus 120 degrees plus 60, 180. Now see, they made a semicircle like 180 degrees. These two also semicircle, 180 degrees. So now here 60 degrees. So here also will be corresponding angles. So angle 4 equal to angle 80. So here 60, here 60. These two also, angle 3 and angle 4 are linear pair angles. So here also we have to get 120 degrees. And here also we have to get 120 degrees according to the corresponding angles condition. So in this is very useful. If you know the one of the angle, we can find the remaining, the rest of 7 angles by using transversal conditions. So listen children, you have to be learn this. This is very useful in the higher section completely. This till 10th class, this is very useful. Corresponding angles always equal. That you remember. Corresponding angles always equal. Next, you have to learn about alternative interior angles. Alternative interior angles, and also immediately we will get alternative exterior angles. Alternative interior angles and alternative exterior angles. These are always equal. What are the alternative interior angles? Alternative in the sense, here both the sides of transversal we have to take. In the corresponding angles we have taken only one side of the transversal. In this alternative angles we have to take both the side of transversal. If you are taking interior angles, you have to take only interior angles. If you are taking only exterior angles, you have to take only exterior angles. See, alternative interior angles are 2 and 8. Alternative interior angles. These two are always equal. 3 and 5. Alternative interior angles. These are always equal. Let me write here. Angle 2 is equal to angle 8. These two are alternative interior angles. Angle 2 and angle 8, alternative interior angles. Angle 3 and angle 5, alternative interior angles. Both the side of transversal we are taking left side and right side. And angle 3 is equal to angle 5. Alternative exterior, angle 1, angle 7. One left side we have taken, one more right side. Exterior angles are also equal. Angle 1 equal to angle 7 and angle 4 is equal to angle 6. So here, let me take one example now. Suppose here angle 2 equal to 60 degrees. Then angle 8 also equal to 60 degrees only. Alternative interior angles are equal. Okay, now by the condition here is 60 degrees, this must be 120 degrees because these two are the linear pair angles. Here it has a common vertex and common horn like a semicircle. So it is 120 degrees. So here alternative exterior angles are equal. No? Here also will be 120 degrees. Or not, here you can apply the linear pair condition. Here also you get 120 degrees only. Now here you get 60 degrees. See, here you get 120 degrees again. Here you get 120 degrees. Here we get 60 degrees again. If you know one of the angle, we can find the rest of angles by this condition also. So remember what is meaning of alternative interior angles? Here both the side of transversal angles are known as a alternative angles. If you are taking interior angles, we have to take in the cross with 2 and 8, 3 and 5 alternative angles. 1 and 7, 4 and 6 are alternative angles. They are always equal. The next one and last one, vertically opposite angles. Vertically opposite angles are always equal. What are the vertical opposite angles here? See, angle 1 and angle 3, vertically opposite angles. Vertically opposite angles. Angle 1 and angle 3 are vertically opposite angles. If two lines are intersecting each other, these angles are known as the vertically opposite angles. These angles are known as a vertically opposite angles. See, here angle 1 is equal to angle 3 and angle 2 is equal to angle 4. Angle 2 is equal to angle 4, also called as the vertically opposite angle. Here angle 5 equal to angle 7, angle 6 equal to angle 8. These are always equal, children, in the transversal condition. When two lines are parallel, one line is intersecting two parallel lines, the intersection line is called as a transversal, and then and there is 8 angles will form. The 8 angles will be act like this according to the corresponding angles, according to the alternative angles, according to the vertically opposite angles. These conditions we will write while doing problems. There, if you don't know what is vertically opposite angles, what is alternative interior angles, what is the alternative external angles, what is corresponding angles, if you doesn't know this information, there you will face very difficult to solve the problems. Ultimately you will decide that I don't know this, so better to not to do the maths, I don't like maths. These kind of things will play in your mind. So aware that, learn here itself very clearly. Once again you watch it. If you did not understand what is corresponding angle, what is alternative interior angles, what is alternative external angles, what is opposite angles, what are the types of lines are there, what is point, what is line segment, what is ray, what is line, and what is parallel lines, what is intersecting lines, what are the intersecting congruent lines. This all you should know that, and whatever the angles, what are the types of angles are there, what is adjacent angles, linear pair angles, okay, supplementary angles, complementary angles, conjugate angles. This whole information I have given in this video. Once again you watch it. If you understand, that's better. If you did not understand, comment me in the comment box or not call me directly. I will reply you. Okay. I hope you understand this class very clearly. Mainly this angles made by transversal is very important to you practice a lot. Thank you for watching. Keep smiling, children. Bye.